11, it's a fairly simple sort of graphing problem. So we need to consider this equation right here, which does look a little bit nasty. The first thing that I will proceed to explain is that they tell us that x cannot equal, whoops, let me try that again. We all deserve a second chance. That x does not equal 0. Now, why would x not be able to equal 0? Take a closer look at what you have here. So you have an equation that says f of x equals 3x squared minus 5 divided by x. And they tell us that x cannot equal 0. So oftentimes, depending on how our equation is written, there are certain values that we can never take. For example, if I were to have something like f of x equals square root of x, okay, then I would also have to say that x has to be greater than or equal to 0. Because if you go to your graphing calculator and you try to do square roots of, I don't know, -4, you get a mistake. Actually, there are answers to this, but they aren't real answers. They are imaginary numbers. All right. And so if you were actually to graph this, for example, in decimals, what you're actually going to find is f of x equaling square root. Actually, can I do square root like this? F of x equals this. Notice you don't have any negative values, only positive ones. And so there's certain things you have to watch out for which help you define your domain or your range. All this is helping you is defining your domain. Domain, let's remember, are your possible x values. Okay, so here they are telling you that x cannot equal 0 because of something that's here. And the special thing here is not a square root like I showed you down there, but it is the fact that x is in a denominator. And so notice, x cannot equal 0 because if x were equal to 0, well, what would happen? You would have 3 times 0 squared, which is just going to go to 0, minus 5 divided by 0. And what is 5 divided by 0? Well, if you ever forget, check with your calculator. Your calculator explodes. You cannot divide by 0. This is what we call undefined. Okay? So x cannot equal 0 because in the denominator you have an x, and the thing on the bottom cannot equal 0, right? And so if the thing on the bottom cannot equal 0, then x cannot equal 0. See? So that's the first thing I'm going to mention. That's why that appears. See? And believe it or not, it's actually very relevant for part C, but we will talk about that in a second. See? So for now, that is the context. They give us a little bit of the domain, and they tell us that the graph of f, so basically just our equation, is graphed for our values between 0 and 5. Okay, so all of this clearly has already been graphed, but it hasn't been graphed yet on the left side, which is actually what they ask us to do. So for part AI, we need to sketch the graph for the negative values of x. Right now we have the sketch for the positive values of x. Now we need to sketch for the negative values of x. Okay? Now, there's a couple different things you can do here. See? Because you need to sketch for the negative values, technically you can go ahead and find out what is y when x is -1, when x is -2, when x is -3, when x is -4, and when x is -5. Like that can be good enough for sketching your graph. So basically you would find 5 different points and see what happens from there. Okay, now of course, let's think about the most efficient way to do this. And of course, we will be using the graphing calculator. So the 2 main approaches that I suggest is, well, first of all, yes, use your graphing calculator. And for that, because we need to sketch it, you might as well graph it. Okay, so go to your y equals, and in your y equals, you're going to be plugging in this. Actually, sorry, you're going to be plugging in this as your y1. Okay, so if you go ahead and plug in that as your y1 up here, you end up with 3x squared minus this fraction. So for the fraction, to plug it in more easily, you can do alpha y equals and press the first one. Boom, you're putting in a fraction. Yeah, so you can go ahead and graph this, right? Now, The friendliest way to approach it is literally graphing and putting in the window. But before that, I'm going to show you finding these specific points, okay? So a quick way to solve this, you might already be thinking, is that you plug in one by one, right? Like technically you can do it like this. 3 times -1 squared minus 5, right? Divided by -1. And you can do this a bunch of times and change the -1 each time, right? And you're going to get the answer, like you're going to get there. But a slightly quicker way, okay, is once you have it on y equals, you can actually pop up a table. So instead of pressing graph, you put second graph to hit table. And from here you can see, here are the values of x. So when x is 1, y is -2. Makes sense. When x is 1, when x is 1, y is -2. That would be like right there. See? Makes sense. When x is, for example, I don't know, 5, ¿cierto? Y is 74. Makes sense. When y is 5, y is around 74. Checks out, ¿cierto? So you can do the same for the negative values. You just got to scroll up. And from here you can graph, right? It's in fractions, so you might have to simplify it or eyeball it a little bit. But eventually you're going to find out. See, for example, if -1 is around 8, so -1 is around 8, that would be like here. And you also know that -2 is 29 divided by 2, so that's around 15. So -2 is around 15, that would be like there, ¿cierto? -3 is 86 divided by 3, that would be like a little less than 30, so a little less than 30, maybe there. -4 is 197 divided by 4, that's around 50, ¿cierto? So around 50, I guess you could leave it like here. And then -5, okay, is 76. So -5 would be, boom, all the way up here, right? And you can already notice that there is sort of a curve happening here. Like it does seem to slow down a little bit there, ¿cierto? So on the one hand, you have that going on, right? So it has some sort of curve. But the other thing, because you're sketching, and really this is probably the best way to approach it, I'm just showing you all the tools you can do, is literally just graph it. That it. Now the small issue that you're going to encounter is that if you literally just graph it, you do have to play around with your window. The challenge of graphing is that a lot of people have trouble with the window. See? Now how does the window work? The window, the main thing you need to be focusing on is x-min, x-max, and y-min, y-max. You should not be changing anything else because you don't have to change anything else. And so take a good look here. It's very apparent what I have to do. This is going to be your x-min because it's your smallest x value. This is going to be your x-max because it's your largest x value. This is going to be your y-min because it's your smallest y value. And this is going to be your y-max because it's your largest y value. So once you establish that, it's suddenly very easy. So y-min is -5. Y-max is going to be 5. Y-min is going to be -60. And y-max is going to be 80. So graphing from here, doop-de-doo, is suddenly a lot more simple. So clearly, the pink dots that I put here are like good enough, but I do need to acknowledge that it goes all the way up like that. See? If you want your window to be 100% accurate, notice that each of these squares, it's jumping by 1, right? And each of the squares on the y-axis is jumping by 20. So if you want to make it like super duper mega accurate, you could change your YSCL to 20. The SCL is the scale, like each square is going to be 20, right? For the X, each square is going to be 1. So now you can graph, and now you end up with something literally like the diagram showing. See? So a lot of blah blah, a lot of window context. Point is, for you to get the full sketch points, you have to put a little bit of a curve, and then you have to make it go all the way up like that very violently. Okay? So a lot of blah blah, but I do want you to have all the tools available. So one of the tools is clearly making a small table, finding each of the values, ¿cierto? Using the table function. But the more friendly one, to my knowledge, is simply just graphing, acknowledging what is x-min, x-max, y-min, y-max. And if you want, you can change the SCL. It wasn't completely necessary. really for sketching, especially an exercise like this, you need to nail like the general form. So the one point is definitely going to be landing the curve, and the other point is going to be landing that here it goes straight up near x equals 0. See, so near x equals 0, it goes straight up. You got to acknowledge that, right? So on the one hand, it's the curve. On the other hand, it's just straight up. So if you actually look at the mark scheme, you find something very similar to that. It says on the one hand, you get a point for the correct shape. The curve must be smooth. Asymptotic behavior, which is it going all the way straight up. And generally, you just get points for like nailing the dimensions of it. See, so nailing that the minimum is somewhere near there, that the highest point is somewhere near here. I mean, all that kind of stuff, you can do it if you eyeball it correctly. See? So sketching is easy points. You just have to make sure you replicate correctly how it should look like. See? You have the graphing calculator in hand, so do not hesitate to use it. Okay? I think the friendliest approach is literally just changing the window and graphing. But it will show you all the tools because you never know. Yeah? So that's for part AI. For part A, double I, we need to write down the x-coordinate of the local minimum point. So clearly, you need to find the point that's somewhere down here as the minimum. Okay? Back to the graphing calculator. From here, now that I have it all nice and graphed, there is a minimum function you can use. Okay? And you will be calculating the minimum, which is why you need to press second and then trace in order to hit calc. Here are all the functions you need to use. Finding zeros, finding minimums, finding intersects. In this case, we will use minimum, of course. So what does it ask for? Notice, it asks for a left bound, and later on it asks for a right bound. And I'll explain this in a second. So if my left bound goes from here to here, for example, all it's going to do, notice the dotted lines that it's putting up there. See? Not all calculators show the dotted lines, but all calculators are doing the dotted lines behind the scenes. So basically, you're asking the calculator, within this area, within these two bounds, give me the minimum. And the last thing you have to do is press guess, and this is only if within those two bounds, you have more than one minimum. Your calculator doesn't need help guessing, let's be honest. But the guess function helps you choose a minimum in case you had more than one. In this case, there's only one, so you press anywhere near, boom, there's the minimum. Okay, so the x-coordinate of the local minimum for part A, double I, you have to specify that your y1 was this guy here, so your y1 is 3x squared. And this is just for the procedure point, just in case. So your y1 is this, then you did calc min, and you ended up with negative 0.941. Three significant figures, I can leave it like that. Actually, I'll show you how I do that in a second. So this is the x value, and then this is the y value, 7.9699. If you want to do significant figures, you have to count 1, 2, 3. Do you round it up or keep it the same? You keep it the same. So you can leave it, your final answer, as negative 0.941, comma, you count 1, 2, 3, round it up or keep it the same. You round it up, comma, 7.97. Okay, so the x-coordinate for the local minimum point, so x-coordinate min point is negative 0.941. And just so that you all trust me, it's showing right there. Okay, yeah, so that is for part A double A. Then for part B, we need to use the graphing display calculator to find the solutions to the equation f of x equals 20. Now, this is extremely easy, but it's probably hard to interpret, okay? It's probably hard to understand what it's actually asking for. So, first things first. Guys, at some point, probably between middle school and high school, you started realizing that this inside is your x, okay? And this whole thing, f of x, is your y. That's all that's happening, see? Why is it useful to write it like this? Because then you can end up with tables like this one, which is basically asking, this one up here is saying, when x is -1, what is y? That is why it's useful to write it in these sort of parentheses. Okay, when x is negative 1, what is y going to be? So basically here what it's telling you is that it's putting in a y equals 20. I need to find the solutions to the equation of y equals 20. The other way that you can think about it, because I think visually it's extremely appealing what I'm about to do, technically you can draw a line at y equals 20. And how would a line at y equals 20 mean? Well, in Desmos, if you go ahead and put y equals 20, what do you end up with? Well, think about it. You end up with a line that goes horizontally through 20. Now you might be thinking, why is it horizontal if we're talking about at a y value? Because your x value changes, but your y value doesn't. Notice, I always have a 20 here. The 20 is not changing. So for drawing a horizontal line, you have to leave a y value that is fixed. That's why it's y equals 20. Now for drawing a vertical line, you do x equals, I don't know, 3. And so here you have a y value that changes, an x value that doesn't. So I hope you learned something new. Anyways, so back here, if you think about the solutions to y equals 20, you're putting a line that goes like this. Just like that. See? And so what are the solutions here? Well, the solutions here would be wherever my function, which is the line that I'm putting in red, the curved line here, and this line here, it's wherever the purple meets the red. And so your solutions are how many, you guys? Are 3. You have this solution, and this solution, okay? And there's a couple ways to find it. On the one hand, you can do an extremely hardcore math way, which is saying, okay, I need to have that f of x equals 20, and I also know that my function is f of x equals 3x squared minus 5 over x. So technically, you can combine these and say 3x squared minus 5 over x equals 20, and try to solve x from here, and eventually you're going to find that you have 3 different x values, and through that you will be solving the solutions. Figuring out the solutions. So that's one way you can do this, okay? Now that sounds like a headache, let's be honest. Solving this looks insane. But what you can do is notice, here they are equaling each other. But really these are 2 lines, right? The horizontal line and your function. And so wherever they're equal to each other is where they intersect. Bada bim, bada boom, that is our procedure now. So you go back here and you say, okay, this is going to be y1, this is going to be y2. And so you go back to y equals, you put y2 as 20, you graph it, and it's the same thing that I drew up here, but the color is a little bit different. Whoops. And you can go second, trace to hit calc. Now you're calculating intersects. And now is when the guess function makes a lot more sense. So the first curve is the blue one, makes sense. All around it, it's the blue one, ¿cierto? And the second curve has to be the one that's red, okay? As long as you press left to right, you're gonna be fine. The only mistake that can happen here is you press up or down. If you press up or down, you do jump from one function to the other. So just focus on that, press left to right. So the first curve is the one in blue, the second curve is the one in red. And with the guess function, now again, your calculator is not dumb. It knows all the intersects. It knows the 3 intersects. But what it does need to know is, okay, which one do you want? So we're going to start with the one on the left. So guess around near it. And there you have it. So the first intersect, we're going to write it as, well, I'll leave it in light green. So the first one is at negative 2.45. Okay? I'm leaving it in significant figures, you guys. Okay, you can leave the whole answer, it doesn't matter, it's still gonna work. Yeah. For the next intersect, again, you gotta go second, trace, go to intersect. Same idea. First curve, make sure you're clicking the first curve, the blue one. Second curve, make sure you're clicking the red one. Again, you gotta guess for the one you want. It's around here. There's my intersect. So your second answer is going to be negative 2.52, negative 0.252. All right, and this last one over here, running a little bit out of space, but I think you guys can figure it out. So here's my first x, here's my second x, here's my third x, my third solution. So that for the last time, I go to intersect. First curve sounds fine, second curve sounds fine. And for the guess, I'm gonna go all the way to the right. Go ahead and press enter. There it is. So for this last one, in significant figures, it would be the 9 is gonna turn, well, you're gonna round it up, so you actually end up with 2.70. Awesome. So 2.70 will be the last solution. So using the graphing display calculator, finding the solutions, it's 3 solutions because it touches 3 times. Using calc intersect, you found all 3. You go over here, and there they are. Negative 245, negative 252, and last but not least, 270. All right. How do you show your work? Well, actually here there aren't any method points. Okay. I'm kind of surprised there aren't any method points. It's kind of weird. But just if you're a little bit nervous and want to show your method points, this right here is good enough. You're showing that you're putting into your calculator as y1 as y2, and that you're doing calc intersect. Write that down somewhere. Make sure you get those points, okay? That is for part B. And then part C is very easy, and you can actually do it skipping part A and skipping part B. Part C, you need to write down the equation of the vertical asymptote for the graph of f. Now, first things first, what the heck is an asymptote? Guys, an asymptote is a number, okay, that your function gets very close to, but it never touches. Keep in mind that you have 2 types of asymptotes. You have vertical asymptotes and horizontal asymptotes. Okay, so for example, you have vertical asymptotes and horizontal asymptote. In this case, you have a vertical asymptote which actually runs, or goes through. Let me raise a little bit of this because there's a lot of stuff written on here, see? But keep in mind, so an asymptote is a value or number that your function never reaches. And that can be for x or it can be for y. That is why we talk about horizontal asymptotes and also vertical asymptotes. So in this case, you have a vertical asymptote that goes like this. Wabow. This is a value that your equation will never touch. Visually, it makes sense, and there's one other very strong argument. Okay, so guys, first things first, this is a vertical line. And what did we say about vertical lines? For putting vertical lines, you need to leave an x value that is set. See? Because again, you have all these different y values, but the x value stays the same. And so in this context, the equation of your vertical asymptote is x equals 0. But wait, you saw that before, right? Earlier we said, and this is very interesting, earlier we said that the domain was that x could not equal 0. And so because x cannot equal 0, the vertical asymptote, its equation, is at x equals 0. And so because x can never equal 0, your vertical asymptote is at x equals 0. And I know that's a little bit weird, so let me talk a little bit more about it. Let's remember, I said an asymptote is a number that your function gets very close to, but it never touches. And so because x up here cannot equal 0 because it's on the fraction, on the denominator, ¿cierto? That means that if I were to say, all right, because x does not equal 0, that means at x equals 0, I have an asymptote. Because the asymptote is the number that you get very close to, but you will never ever touch, okay? So fairly simple, the equation of the vertical asymptote is at x equals 0, see? A very common mistake is that people say, okay, the equation is that x does not equal 0 because I associated 2 asymptotes, so I'm good to go. Nuh-uh, it's not exactly like that. Because x cannot equal 0, your vertical asymptote is x equals 0. If I were to be very rigorous with this, it's basically because this is your domain, then your vertical asymptote has to be this. All right, that's the way you think about it. This is your domain, and because of that, your vertical asymptote has to be that. Okay? Ladies and gentlemen, part C just so you know, you can solve it without doing part A or part B. Once you get familiar with domain and how all this stuff works, you can actually get this point very quickly in less than a minute. I mean, you can look at it and immediately say, boom, that has to be a vertical asymptote. Okay, so keep in mind, that's the sort of stuff that gets you that gets you points, especially when you're low on time. Okay, be on the lookout for these type of exercises. For part C, you do not need part B or part A. Okay, so keep that in mind. Even if you suck at sketching, you can do part B without part A. Okay, you just pop it into a calculator and work from there. You don't need part A for part B. You don't need part A or part B for part C. So be on the lookout for those kind of details. They will give you points, especially when you're low on time and you need to be ultra mega efficient. Keep in mind, just whatever helps you, whatever floats your boat. I hope it helped. And that's number 11. We'll see you around.